Can machines be creative? Can physical robots do things that ordinary people can do? Even the more philosophical questions of can machines be self-aware? Can machines have free will, emotions, creativity? Can it be put into a machine? Something happened in AI that has changed completely.
Us as humans, I always feel that, something that we've seen or we have in our subconscious mind, we are probably able to imagine some stuff better. From a machine standpoint, it only has context on the data that it has seen or it has consumed. So then for something that has totally not been seen or experienced, then how does the imagination work and how it could evolve?
These glasses that people wear now that have cameras in them, you know what the real reason we need these glasses is to train robots.
You ask any AI expert today, they're like, you know what, curiosity and creativity are the only skills that are really important for humans.
We have the secret saying in our lab, if your hands are dirty, your job is safe.
How do you see role of some of the CXOs changing? How does the role of a CEO changes? Let's say a CIO, a CFO, a CHRO, or a CMO. Any take on that, how do they look at future evolving? Okay, all the way from New York, we have Professor Hod Lipson with us back here again in India. And this time, apart from Tech HR, we have you here as part of the Humanscope podcast as well. Thank you so much for joining us.
It's my pleasure.
What has changed, Professor, since you visited in 2019 and 2025?
Everything has changed. In the world of tech, AI has just turned the world upside down. Everything has changed. And as a derivative of that, robotics and how people work and how people see the future, finances, politics, and everything has changed. But I would say from the biggest thing behind the scenes is AI is really changing almost every aspect of what we do and how we live.
Can you break down your work and how has your work also evolved for a lot of our viewers? They would love to understand where you started and now over time, how has your work evolved in your area of expertise as well?
So I've been interested in robotics and artificial intelligence for a long time.
Yeah.
Specifically in the sort of hard problems of AI, which were things like creativity. Can machines be creative? Can physical robots do things that ordinary people can do?
Yeah.
Even the more philosophical questions of can machines be self-aware? Can machines have free will, emotions, things like that? I've been trying for, I'd say, 2 decades now to try to really push the limits of AI and robotics to where it hasn't been before. We can talk later about things like can robots grow, robots reproduce and make more robots, things like that are almost science fiction, but they're happening in reality. So that was going on for about 2 decades. We've been working on this. My work is as a professor is mostly in research. So there's about 20 to 30 students in my lab that come and do research. Some of them do 1 semester, some of them do 5 years. It's different, lengths and depth of research. But I would say since I was here last time, so in this period of about 6 years, something happened in AI that has changed completely what's possible.
Yeah.
And sometimes I hear people say, it's been behind the scenes brewing, and now the public is aware of it, but it's actually not true.
Okay.
This is really something that happened suddenly, and it surprised even the people in the AI business themselves. So we are kind of scrambling to keep up with this because it's sort of gotten a life of its own. It's moving forward at an incredible pace. A lot of things that we didn't even think are possible or weren't even on the radar suddenly become possible.
What initially got you excited into this field, Professor? If you could go back a little more and sort of share with our viewers.
So personally, I was for many years an engineer, a
Yes.
design engineer. This is sort of what I was originally trained. And as I was, my initial job was a design engineer, is designing things.
Yeah.
And quickly I realized, or I got sort of frustrated with this idea that you have to keep designing things all the
Yeah.
time, over and over again. You have to design the chair, then you have to design another chair, and a table, and a lamp, and a camera. You have to keep designing the same kind of things all the time. Wouldn't it be great if we can design something once and that thing can design everything else for us?
Yeah.
Like, it's the meta problem of design. Instead of designing lots of things, design one thing that can design all the chairs forever. You don't have to design a single chair ever again. Design something that can design tables, and it can design all the tables for you. You see, there's a laziness.
Yeah.
We just want to, just get something to do it for you. So that was my sort of passion. I saw it almost as both a practical thing, but almost as a philosophical question. Can this mysterious thing called creativity, can it be put into a machine?
Yeah.
It's both a practical thing, because if you can do it, you can do a lot of things.
Yeah.
But it's also a philosophical question, because is creativity something that is uniquely human, or is it just a process that you can pack into an algorithm? And for many years, it was a fantasy, but now the answer is obviously yes.
Can you break this thing down for our viewers on the whole aspect of creativity and just this essence that you talked about, that, can it actually be planted in, or can it be evolved into machines as well? And what has been your discovery as part of this whole journey?
So there's basically sort of two approaches to making, in the end, to sort of creativity.
Yeah.
And we see them in real life all the time. The first one is our human brain,
Yeah.
or animal brain. It's neurons that work together, experience things, and then create new ideas. And the second source of creativity, which we sometimes take for granted, is evolution. Okay, it's out there, it's a process, and it creates everything. It created us, it creates plants, it creates animals, it creates incredible things that nobody could argue are not creative. Very creative solutions to lots of problems, but it's not a brain. It's a process. It's an evolutionary process that's out there, very different. So these two things, we, the AI community, have put inside a box. And they both have this fascinating aspect that they involve very small things, very small processes that repeat millions of times, billions of times. And each step is not very creative, but when you repeat it a billion times, you start creating really creative things. And that's true for evolution, and it's true for generative design, for generative AI. Both of these processes are generative. They happen billions of times, and they create new things.
Professor, and I know, you've done a lot of work around the robotics field, and machines have evolved as well as we go. Let's say 10 years back, 15 years back, did you feel it will evolve so fast? Was that something that you were thinking and working? And what has changed?
Designing and making things to solve problems is really, really hard. And we humans are very, very slow at it. Very, very slow. It takes us, decades to come up with a new medicine. We're very good at designing chairs and hammers, but we're not good at designing complicated things. For AI, what has happened in the last couple of years, this question of how to design and make things automatically is now sort of being solved. And you can see that one by one, we're accelerating in solving things. We're making new medicines faster. We're making new materials. We're making a lot of things now that took us decades are going to happen in months. And that is, you're going to see this effect happening across the field in many, many areas, starting with sort of medical, but it's going to be everywhere. because it sort of accelerates things. And behind the scenes, I would say, if you ask why is it happening now,
Yes.
what's the driver?
Yes.
The sort of computers are faster, much faster than they were just 5 years ago. Next, in a decade, they're going to be even faster. So this is why it's not going to slow down. A lot of this technology is based on data. Data is fueling a lot of this, and the amount of data that we're collecting is also growing. So we have faster computers, and we have more fuel. Think about as if we have a car, you have faster cars and you have more fuel. All right. So both of these things make you sort of go to places you couldn't go before. On top of that, and this is hard for people to sometimes understand, we have bigger, more capable AIs. So the brains themselves are growing.
Yeah.
Okay. So it's not just that you have more data, more computing power, but the capacity of the brain to learn is growing. So not only have faster cars and more fuel, you have bigger engines.
Yeah.
So they can carry more, if you like, the capacity. And then on top of all of that, you have multiple AIs working together. This is the hardest thing to understand. But it's like, we humans, we can do a lot of things. We can't do much alone, but we can do a lot together, right? So as civilizations, we can build erect things that no single human can do alone. We work together, we create economies and civilizations because we work together. AIs now are beginning to work with other AIs. This is something that most people don't see. They see one AI at a time. ChatGPT, Gemini, who should I use? Behind the scene, there are hundreds of thousands of these AIs, and that ecology is beginning to grow. And you don't see it because it's all hidden in data centers, but that is going to unleash an incredible power. So in other words, if you think the car analogy, which we just started, the cars are faster, we have more fuel, they're more powerful so they can carry more load, and there are more of them. Okay, because once there are more of them, you can start having fleets and do things you can't do with a single one. So if you put all that together, this is why we're seeing this incredible exponential growth, and it's nowhere near being saturated. So there's a lot of upside still to unfold, and this is where I'm on this crusade right now to get people to realize this huge new world is unfolding. We just discovered this incredible capability. It's pure horsepower, and it wants to do stuff, and we have to step in and drive it. We need to steer it in the right direction, especially people listening to this podcast, people who actually make decisions can drive this in the right place. This is an incredible moment.
Professor, deeply you explained about the creativity part of things and how it is sort of evolving. What about imagination? Because we've always thought that, humans can imagine and machines could execute. But a lot of that lines have blurred.
Right.
And I'm sure a lot of discovery you and your students would have had as well.
Yeah.
So if you could throw some light on that.
So let me explain to you how this imagination happens in a machine, all right? I'm going to use a analogy of creating a photo, right? So it starts by training. You take a picture, let's say of an apple.
Okay,
a photo of an apple. And you remove one pixel. So you take one pixel in the middle and you remove it, okay? And you tell the AI, fill in the missing pixel. Okay, so it's easy. Fill in a missing pixel. It's not creativity, right? Just one pixel. Usually it depends on the pixels around it, average, so no problem. So we do that 1 million times. Different pictures. Remove this pixel, remove that pixel. Trivial problem. Then we do it again, but we remove 2 pixels. Fill in 2 pixels, a little bit bigger. Then remove 4 pixels. Then we remove 8 pixels. Gradually, we make that blank that we take out a little bigger.